Got it. Remember the old days when they didn't have to warn you. All right, the first thing I'd like to say is I'm Kevin Appert. I'm the program chairman of SVFIG, and it's all my fault. Whatever goes off the rails, embrace it. All right, the last time I heard everybody was okay with adding order. If you're not, just send me a chat message or something and we'll see if we can shuffle it around to suit you better. Coming up in November, you would think that, oh, that's off the radar, that's too far away, let's not worry about that yet. I have learned from prior experience that you'll be calling me at midnight the night before saying, oh, could I get a talk in on 4th day? It all tends to come together at the last minute, but hope springs eternal. We'll be able to organize this a little bit better well in advance this year. So if you would care to present, think about what you're going to present and get it lined up and send me as soon as possible some kind of missive about the details, subject and title and 2-line description would be great. Of the sort that you see on Meetup or whatever for all of our meetings. If you know somebody that you'd like to have present that doesn't hear the sound of my prattling on a regular basis, now's the time to either suggest that I reach out to them or reach out to them yourself. And finally, if you want to help, I don't want to use the word organize, that may be a strong word. If you want to get this show on the road, this barbecue in motion, communicate with me directly. I'd be pleased to have your help. It's a substantial amount of fiddling around, and I bet you I could knock off a chunk or two of the job for you. So, without further ado, our first talk, a generalized 2D data structure for 4th. This is part of a series, I can tell. Bill Ragsdale, you have the floor. Oh, if you aren't muted and you aren't Bill Ragsdale, now's a good time.
Very good, thank you. Let me get over to share screen. Very good. This is slightly different than my normal format. There are 14 points to this talk, so I would like to have questions and comments item by item rather than at the end, because if we go back to the end, we've got 14 things to talk about. So let's try to take them. Any questions? I'll do a pause at each phase of it. And so we're going to do these 14 different tools for testing, debugging and testing. And my little disclaimer is that I certainly don't use them all every time, but I grab 1 or 2 or 3 whenever I'm involved in program development. And you all know some of them, but I'm not sure everybody knows all of them. So it's a little cookbook or recipe book for you to choose from. And as you'll see at the very end, the material is posted at GitHub. So you can see the full set of slides there. This is built on Win32.4. It has several debugging features that may not be in other systems. I think the way it'll probably work is that most systems will have, of the 14 items, most will have maybe 10, 11, 12, but the only system I know that has them all is Win32.4. It's using the words see, view, and debug, which are very elaborate debugging and analysis programs. So here are the 14 tools, and I will review them for those of you who have difficulty in speed reading, and you'll get ready for your favorites which lie ahead. The simplest, of course, is to test using command line input. Then you can take your command line text and write it as a definition. And then you can take that back to the command line. And of course, in writing the definition, you want to make sure it'll compile. The next step is to rewrite the code showing all the parameters in the source code for element by element debug. Then we'll introduce the fourth C, which is a disassembly, the fourth view, which gets you to source code. Then an example on how to create a test data set. Then how to set breakpoints in a simple way using exit, using .s to display internal computation, and then an active test reporting sequence where you can write messages to yourself using if else then. Then an error trapping using abort quote, which I'm sure we all use, and then how to integrate the testing with a wrapper word. And then finally, the debug, which is really more of a trace than debug in Win32. And I must say, I only discovered this in the last month or two. I've been using Win32 Fourth for 4 or 5 years. And I only discovered that it had this debug word and how to actually use it. Because the only way to learn Win32 Fourth is to go back and read the source code. And I keep discovering things every time I read the source code. And the commercial is though that I've written an 80-page manual on using it. And then finally, at the end, you can use selective computation to manipulate actually your object code. So here's the first simple one. This is really easy. Let's pretend that the examples we're going to be using very simple operator, just plus, minus, times, and divide. So let's imagine that you recompiled your system and you've made some changes way down at the low level, and you might have changed the way divide works or one of those. So you want to test the whole sequence. So in this case, I want to test the plus, minus, times, divide. And so I'm going to develop a sequence of 5 integers and then execute them against this sequence. So you see at the actual screen capture of the code, my test sequence for all these tests will be 12,000, 3, 270, 30. And after you run it through the plus, minus, times, divide, you should get the number 40. And if you do this from the command line, as you see, after that sequence, there is a dot, and you'll see the 40 as the correct answer. And of course, if you don't get 40, then you have to delve back into inside the code. Well, you very quickly get tired of testing the test numbers and all the commands. So then you can rewrite the plus, minus, times, divide. That is the operators that you're testing, write them into one word. And then you see that the input, of course, is going to be the numbers, 5 numbers, N1 through N5. And the output is N6, which is the result of computation, which you can use for further testing. So the second step is form a definition. And of course, the very important part is writing under in the comments section, either a word or mathematical description of what's going on. And so there you can see how the reverse Polish notation works itself out into an infix notation. So any comments so far? All right, this is not quite high-powered stuff, but it's essential. So the next thing is to test using fewer typing errors. Now we compress the plus, minus, divide. Oh, the reason for that prior test was to make sure they'll compile. Some of the words are more elaborate, of course. You may or may not, and you have typing errors, you may or may not get it to compile. So now that we've got it to compile, now we type in all of the numeric values, and then that one word math, which does the exercise, and then dot to see the output. And sure enough, there's the screen capture where I type in the numeric values, the word math, the dot, and I see 40. So test number 3 is okay. So now if I'm getting into trouble, especially if it's an elaborate definition, very often at the start, I will write out every line of code and then the parameters. It's particularly important when you see, in this case, there are 5 parameters. And in my matrix work, there are as many as 15 parameters on the stack. So writing out the entire stack contents every step can be very, very important. So again, we see the definition, but this is within the definition in green. is the stack contents at each step. And so we proceed down the way till the very end, and we get that last summary of the entire operation with the divide. So now we get into the fun things in Win32.4. And this is the word C. And in this case, C goes into the running object code and decompiles it. So you can see if you have compiled what you think you have. And we'll see it operate next. And there it is. If I type C math, it will type me the decompiled math right out of object code. And Andrew did a beautiful job on this because it will handle things like bills does, and it will handle conditionals and branches and loops. It does an amazing job. They've actually buried into the dictionary elements that facilitate this. And also there's inside the source code, there's an index of all of the words like do var, do colon, do does. There's a major analysis debug resource built into source code. So there's the quick one. See what's in the object code. So now let's look at the source code. In this case, if you type view math instead of C, it will go back to your source code. And in each definition in the header, there are some links to the line and the file. So as you compile code from source code, the compiled object code in the dictionary actually has links into your source code. Sure, it chews up memory space, but you love it when you can use the resource. So if I just type view math, it comes back to source code and it highlights the source code. In this case, it highlights the second line of source code, which is usually comments. So when I type view math, it brings up on line 34, 35, and 36 the definitions. We see the input parameters. The backslash is the action. In other words, this case, the mathematical operation, and then our plus minus times divide. So do we have any questions on using view or C? How many of you wish you had a view or a C? Wave your hand. Yeah, okay. And again, this has been like an Easter egg hunt. As time has gone by over the last couple of years, I discover these words in the source code because they, for example, don't give any examples of use. You just see the word C, and yet you don't know what it does until you start to try it out. So now to simplify our testing and debugging, we're going to take the data set, that 12,273, make that into a word. Now, this is one of the absolute fantastic capabilities of Forth, is that for testing, you can build data sets as words. And, I'm not familiar with other languages that make it as convenient to create test conditions on the fly, briefly, quickly, write a couple of words, test them, blow them away. So in this case, the second word is output, and output is just a dot quote that says, and you see, and then the dot will print out the result. So if we say input math output, the input will present the number sequence. Math goes through that plus minus times divide, and output prints out the and C, and the number 40 is what should output. So here's an example of a simple breakpoint. I think breakpoints may be buried inside Win32.4, but I haven't found them yet. But here's the poor man's breakpoint. And that is just the word exit, which will exit a definition at any point. So here I've redefined my math word. So it has a plus minus. And after the minus, then I do a CR for a return, new line. and then print after the minus, then a space, and then .s to display the stack and exit. So after the minus, it will display the text. It will print the stack contents and exit at that point. And here's what we see. If we type in data math, then afterwards we'll see the little reminder that says it's breaking after the minus operation. And what's remaining on the stack is the 12,003 and 100. Any questions so far? Comments? So here is a creative use of S. This is essentially a poor man's trace routine where you go into each operation and do a stack dump after the operation. So we redefine the word math, and now it does a stack print, a plus, the stack print minus times divide, display the stack after each operation. And sure enough, there's the output. If we type math, if we type input math, then at each step of the way, we're going to see the stack content, ding, 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 down. And the very last one is the output 40, which is what we desire. So again, this is a poor man's trace. And if we want to do a double check, then we use the word cmath. Now this disassembles what's in memory. And you can see that sure enough, in memory for math, we have the CR, the .s, then we have a plus for addition, the CR.s minus for subtraction, and likewise for multiplication division. So we can correlate in our source code where the .s's are and where they are in memory. So notice how we are flexibly going through this whole suite of testing where we're putting things in source code, we're commenting, we're putting in breakpoints, we're doing a dump of object code in memory. Here's one, if you're doing testing and you want to preserve it for long term, which I do. When I write elaborate programs, I keep all the test routines written in memory so that whenever I recompile, it actually recompiles all the tests. So in this case, we're going to make an error report that is self-reporting with conditional testing. So in this case, if you read the code in red, we input math. At that point, we should have the number 40 for an output. So we dupe it and dot print it, and then we compare it against 40. Well, the conditional branch there says if it is 40, we'll get a printout of is correct. If it is not 40, we'll get an output that says incorrect. And sometimes in this case, I use the bell command, which is ASCII 7. So I'll put an ASCII 7 emit in that line. And so if I get an error, when the thing recompiles, I'll get a ding on the bell, wake up call. So down below, you see what the logic is. 40 equals gives you is correct. Not 40 equals says incorrect. And here's an example of it's an operation where I type the input math. I just type recompile. And what happens is upon recompilation, I get the output that 40 is correct. And here's the ever popular abort quote. Again, very, very valuable. It's essentially another way to do breakpoints and diagnostic. Only in this case, you can embed it right inside your code. So now in the case for math, we're going to embed an error check. It says after we've done the plus minus times divide, we duplicate the number and compare it to 40. If it's greater or less than 40, we'll get an abort, which says we expected 40. And otherwise, we'll get, did get 40. And of course, the number still outputs. Because we duplicated it at the very end, the number 40 will still be output. So this little math word now contains its own internal diagnostic, but it operates just as it would if error-free. And here's the example on that. If we type input math, the output will say did get 40. So it verifies correct operation. Of course, if it did not get 40, we'll get an abort and it will print out the message expected 40 and then error recovery. So now we can integrate the whole thing. We can take all these words and build them into a little test tool test sequence. So in this case, I've named it XXX, and it does our input, our math, and our output. And if you are testing something that's particularly new, irritating or difficulty, you can reduce the entire test sequence to a simple. I usually use 3 letters like AAA, BBB, CCC. Type that at the command line, and you can re-execute your test sequence. So here I just type 3 X's, and it says and C40, just as we expected from the previous use. Now here is the word debug, which in Win32.4 is certainly more of a trace than a debug, but who am I to change the name? What I've done is taken that math sequence, that input, test, output, input, math, output, and I buried it 3 levels down. So the lowest level is the word enter, which does that input, math, output sequence. That's wrapped inside the word enter 2, and that's wrapped inside the word enter 3. So from the top level, at the command line, we can type debug math. The operation then goes into the source code of math, object code. It goes into the object code of math in memory, patches it, links it into a debug routine, and after use, it unpatches it, puts it back in its normal condition. So if I just type debug math and then enter 3, it will execute enter 3, which executes enter 2, which executes enter 1, and that will get down to math, which actually reveals. And here's what it looks like. The 5-element dump is coming into the word. So as we enter the word, we see the 5 numbers of our test suite. After plus, we see that the 70 and 30 have been added together to get 100. Then we see after minus, we get the 70 and 30, 100 have been subtracted from 200 to get 100. After times, it's multiplied to get 300. After divide, the ratio is taken, and we get 40 for the output. So that is dynamite. And if you're having a problem where the code blows halfway through the sequence, we'll see in a moment how this executes in real time. After each line of code, or after each operation, you hit spacebar, and it goes 1 step at a time. So if you're 23 steps into a loop and it blows, you will know exactly the point at which the failure occurs. And here is real life of use of that. We type clear screen, debug math, and then enter 3. And every time we hit the space bar, it executes one operation. So there we go, 4 steps, all the outputs, the parameters in line, and at the end we see the number 40, just as we expect. Any questions on or comments on this method of debugging?
Yeah, I thought I'd add a couple of things about debug, because
Sure.
It's got a couple of features that you didn't mention. Instead of typing the space, you type a Q, it quits, which allows you to terminate it back to the command line. Also, if you type the letter F, say for instance, you get to a point where you go, oh, that number came out wrong, but I want to finish it through the rest of the definition. Instead of 300, it came out with 30 or something. So you could stop it with F, drop the 300 and type it, or the 30 and type in 300, and then hit the carriage return and continue on your debug sequence. And those are a couple extra handy features you haven't mentioned here.
Wow. Andrew, learn something every day.
Yeah.
Thank you. That's good.
So those are a couple things you want to add to your instructions on how to use it.
Good. Any other comments? Anyone else?
I'm not sure if it's the case in this debug implementation, the one that I know. You also have, I would have to look up the exact commands, but the ability to nest into and unnest out of
yeah.
that you're debugging at the moment.
Yeah, it's the letter N. I forgot to mention that. If say, for instance, you wanted to nest into star, for instance, when you get to that line, you just type the letter N and it will nest into the star and then sequence through star with the standard debug things like you see here. So I forgot that one. The one thing that I found that this tool doesn't do, and that's that it doesn't go through execution tables. It does everything else, but it doesn't seem to handle. If you have an execution table where you have an index into the table and then you execute the value that's there, that doesn't. The nesting won't work. But you can put the word in. You know, you can break the debugger and put the word in and debug that new word, but then you don't get to continue on afterwards. So that's the one place where I found that it doesn't work, but it works in almost every other case that I've tried. So it's definitely a handy way to figure out where your stuff went bad, because you can see it right there on the stack.
Yeah, beautiful. Any other comments?
Dwight, can you tell me where you found this out? Since it sounds like there isn't a written manual on using this.
I don't know. I think it's because once I saw debug, I started exploring what it does. And I think those were the main things that I wanted to be able to use. I think there may be other features to it, but those are the only ones that I know about. There's the N for,
so you looked at the source. You looked at the source code for debug. Yeah. Okay.
Probably.
All right.
N, Q, and F are the main ones that I use, and of course spacebar that Bill mentioned. But Q is handy, you know, when you get to the point where you say, well, this is just trash. I know what to edit. I don't need to go any further. You can just get the Q and exit, go back and fix your definition. So, but yeah, I use it quite a bit. There's a few things that it doesn't handle properly. I guess actually execution tables, and also it's difficult to get it to handle data input from the terminal, from in other words, command line inputs. It doesn't always work real well with that kind of thing as well. But everything else, you know, any kind of just normal execution, it works fine.
Yeah,
it's documented.
Very good. Good input. If I remember right from the source code, I think those manual options are listed in the source code. You know, somewhere. I'm pretty sure they're buried. Anyway.
Yeah. Yeah. So
Philip wanted to say something. Break. Philip wanted to say something.
Yeah, I just wanted to mention that Volksforce variant of debug is actually documented in the Volksforce manual. Unfortunately, it's in German. I don't think the English translation has progressed very far as yet.
Well, again, as a commercial, I've written every time I work on Win32.4 and discover something, I write it up in the manual. So I've got an in process, and the disclaimer at the beginning says this manual will never be finished because it skips the simplest stuff and the hardest stuff and does everything in the middle. I guess I could say, but
and where would one go to see this wiki tome?
Yeah, and then finally, the last.
Bill, have you done any file IO stuff? If you haven't, I will try to do a talk on using WinForce for file IO. Not at the November one, but the December one possibly.
I'm right at that point, because I'm doing this very elaborate, complete suite of matrix linear algebra support, and I'm now just getting to the point where I need to bring input in, and so I'm learning. I've written a little starter point for bringing in text files, CSV files, and taking them apart. And so I'm right at that point, because I got to be able to load CSV files into matrices.
Yeah. Well, I can send you the little extra definitions I have that that I usually use over and over again. You know, just like naming the files, opening, closing, those kind of things. The I can after the meeting sometime, maybe we can email and I can show you what I have that can get you kind of started in it.
That'd be great. That's
Yeah.
I appreciate that.
Yeah, because there's a bunch of tricky stuff you have to get by. The definitions that are in there are all very clear, but they're not very useful in that form. You have to add your stuff on top of it to be, you know, kind of the stuff that you want. You know, you just want to go, you know, open input file and then a name, right, on a command line and stuff like that. Those are things that you have to build yourself on top of the words that are low level, you know, file open, file close, handles, things of that sort.
Good. That's wonderful. That's good. I'm right at that point of utility.
Yep.
Because I've got some projects in mind that all have essentially CSV data coming in, numeric. All right, my last point here. In this case, again, this is something that I don't think you can do in any other language than Forth, where you can modify your source code during compilation. Maybe you can others, you can do selected compilation, but in this case, we're doing selected compilation to include diagnostic tests during compilation. So by using if, else, and then, along with this operator test question mark. If test question mark is true, we will include the options. And if test question mark is not true, they will be omitted. So the source code we see there, and we have this sequence if return .s then, and it's selectively put in after every line of code. This is the complete set. First, we declare the value of test question mark and declare it as an immediate word because it has to execute at compile time. And then to initialize it, we can either say do test, set it true, we can do no test and set it to false. So in that example, we say do tests. Now we compile math and it will compile with all those options included. And so this is with no tests, we will execute math and we will just see our normal output where we did get 40 and an okay. And this is with do tests. And so at the upper part, we see under the C operation decompilation in memory is the word math, and then the cr.s is interposed between each operation. And then when we execute, we will execute input math. And again, essentially this is doing the same thing as the trace does. But of course, it can be done selectively at given points. So we've seen 14 different methods. I'm sure you all use some of them. Maybe some of you use all of them. And mentally, you just will click on the one that's going to fit best for a given problem that you're in. So I used to use mostly stack dumps and exits until I discovered debug. And now for the full word trace, I use debug very heavily. It's kind of my quickest choice because you do it from the command line input and it'll narrow down where your difficulty is. And then you may get a little more specific after that. And so finally, the commercial here for my book on GitHub. And here's the location. These slides are on Forth projects under Bill Ragsdale, and the Win32 guide is under its own segment at GitHub. So are there any concluding questions or comments?
I don't know whether it's applicable, but I did put in the chat a link to some debug commands from Open Forth.
Yeah, the
Sorry, open booth.
one
John,
comment.
you're muted.
Yeah, one comment I have is that you know, I abandoned Win32.4 a long time ago, and in favor of E4. And E4 is much simpler, much smaller, much easier to work with, but it doesn't have that extensive debugging tools. So I often have to define a breakpoint. So I just defined a colon break, character return .s, and then use key. Then to test key for a character return. So when you detect a character return, just abort. Okay. So what you do is insert a break into your code at the point you want to see the stack, and then recompile. And when it executes, it hit that breakpoint, it will stop and display the stack. So you can hit any other key to continue execution, but if you have seen enough of it, just hit return, and it will break. It will abort. So this is the one simple routine that I often put at the beginning of my code. And every time I have trouble with that file, I will just insert a break at the appropriate point and to see what's going on. So I think that in E4 there's no such extensive debugging facility, but if you just define a break, then I think usually problems can get rid. You can solve the problem that way. Okay.
Sounds good. If there are no other comments of immediacy, I
Yes.
asked Dennis to maybe mute. Oh, go ahead.
I have a question. I have a raised hand. Bill, a step that I have gone further with the .s is I've typically, or in worst case scenarios, I may have up to 1,000 points or more that I'm looking at debug points within a large program. And so what I would do is define a word that would do the .s, but then drop the top of stack also, so that I would have a one with this word, which was typically less than question greater than. It's just a word. And so that you can see it easily within the source code. But that allowed me to have thousands of these within the code and identify which one it is, where I'm at on each of them. And that helped significantly in larger programs.
Yeah, I thought I would add something also. That F command in the debug, oftentimes when you're running your code, you may not be in the number base at the beginning of that code that you want to look at the data that you're displaying at the time. So when you type the F command, you could type hex, you could type decimal, you could type bin or octal or whatever you wanted, and display the value in a form that's convenient for that particular stretch of data. And that's very handy to use that F command to be able to change the bases on the fly. And that would be a good example. That would be a good example of how you would use that.
That's particularly helpful in my matrix work. About half the stuff on the stack are matrix addresses, and a decimal dump on those addresses is not helpful. So, but an H dot dumps them in hex, and now you see them where they are in memory. Thank you.
as good as this all is, Bill, are we ready to move on?
Onward.
Okay, Joe, are you good to go here?
I'm good to go. Let me share
You're
my
awesome.
screen.
Okay, let us move on then to O'Connor and fourth commands to the spreadsheet.